Sulfuric acid is manufactured using a contact process. This manufacture involves four stages. Stage one involve a combustion of a sulfur to form sulfur dioxide. Write a chemical equation for when we burn sulfur and give sulfur dioxide. What is the chemical equation? So sulfur is there. Look, sulfur though, even though it's a non-metal, but we don't write a molecule because those non-metal which can form a giant structure like carbon, silicon, sulfur, phosphorus, like giant molecular structure can be formed. So we don't write them as a molecule, we write them as an atom. So sulfur, because it has tendency to form, that's why we don't write S2, we just write S. Rest, it reacted with oxygen. Oxygen is a non-metal. So because oxygen is a non-metal, so it exists as a molecule and it forms a sulfur dioxide, so it will be SO2. The equation for a stage 2 is shown that sulfur dioxide reacted with oxygen and it resulted in a formation of a sulfur trioxide. State, what is meant by the term equilibrium? What is the meaning of equilibrium? A 2-mark definition, and it's a repeated question in different past exam papers. So rate of forward, the points you will mention, rate of forward equals to rate of backward. And the second point, there is no change in concentration of the reactant and product. So no change in concentration in the amount of a reactant and product, that's also the second mark. But don't say reactant products are in equal amount. That will be wrong. The energy level diagram, some student, you make a common mistake. They write here time. This is wrong. This is not the time scale. This is the the reaction progress, like how the reaction proceed. So you have to write a reaction progress on x-axis and energy on y-axis. Explain what the diagram shows about the energy change in the forward reaction. So these are the reactants and this is a product. So which kind of reaction is this? Endo or exo? What kind of reaction is this? The reactants have high energy and the product is having low energy. That's right. This is an exothermic reaction. And why? Because 2 marks are there, you have to say. So you have to say the reactant energy, the particle or the reactant energy is more than the product. Energy of the reactant is more than energy of a product. But in terms of bond breaking, the bond breaking energy must be greater than the bond forming energy. In terms of that, should be more than bond breaking for a reaction to be exo. So in terms of bond, it is opposite. Like the product bond energy should be more than reactant bond energy. But this energy diagram is not the bond energy diagram. It is the energy of the particles. So in terms of energy of the particles, reactant should have high energy and the product will have low energy. But in terms of bond energy, the bond forming, the product bond should have more energy than the reactant. Then stage 3, the sulfur trioxide is converting to oleum. This part is actually removed, so you don't have to learn. A sample of a sulfuric acid has a concentration of 0.75. We want the concentration in gram. So to convert the concentration from moles to gram, you have to multiply by the molar mass. So concentration is 0.75. The molar mass of a sulfuric acid, you will use a periodic table for that. The sulfur, the hydrogen is 1 multiplied by 2, plus sulfur is 32, plus oxygen is 16 times 4. So 16 into 4, 64 plus 32 makes 96, and 96 plus 2, so it will be 98. So we multiply this by 98, so we got 73.5 grams. About the calculation, it's you have, because it's of 2 marks. 1 mark is for working out the molar mass, like showing that if you don't show how it is done, if you just write 0.75 into 98, you will, and you wrote the answer, If 98 is seen, you will score 1 mark. And your correct answer is there like 73.5, so you'll score the second mark. So it's not like how you get 98. If you directly write 98, which is a molar relative molecular mass of sulfuric acid, that's also fine. The sulfur dioxide is manufactured in for a sulfur dioxide is used in the manufacture of sulfuric acid. Sulfur dioxide is obtained from a sulfur ore. Name one of these ores. So which ore we can obtain the sulfur? So it can be zinc sulfide or zinc blende. Fossil fuel, if you mention a fossil fuel, as you can see at the end of each question. So if the question was how sulfur is obtained, then you can mention a fossil fuel. That's fine. Here you will mention a if the question was how sulfur can be obtained, but the question was not from ore, like specific name of the ore was not there, then you can mention a fossil, but not in this case. The next stage of a process in a reaction in which equilibrium is reached, describe two features of equilibrium. So rate of forward equals to rate of backward and no change in concentration. Name the catalyst used for this stage. So we use vanadium pentoxide or vanadium 5 oxide. Because they say the name, don't write the formula, write the name of the catalyst. Why is the catalyst used? What is the purpose of the catalyst? To speed up the rate of a reaction. Explain in terms of the particles why a high temperature increases the rate of this reaction. So rate of any reaction, even remember if it's an exothermic or an endothermic, rate of reaction always increases. So the points you have to mention, a high temperature increases the rate. So what are the points? High temperature, more kinetic energy, that is one thing. Then more collisions between the particles, more kinetic and speed is actually the same idea. More collisions, more successful collisions are there. And greater proportion of the particles have energy more than activation. Rate of forward and rate of backward both increases when we increase the temperature. Because the rate of a reaction is proportional to temperature. So even if it's an endothermic or an exothermic, when we increase the temperature, the forward and the backward, both reaction will increase. So rate of high temperature, rate of forward will be faster and rate of backward will also be faster. But the equilibrium will shift up depending on what is the forward reaction. If the forward reaction is exothermic, equilibrium will shift towards left. If it's an endothermic, it will shift towards the right. In this stage, a moderate temperature 450 is used. Suggests why this what this suggests about the forward reaction. So why we did not use a very high temperature like 1000 or 1500 or 1300, which shows that this forward reaction is exothermic. We use a moderate temperature. Why not a very high temperature? Because the forward reaction is exothermic, and if we increase the temperature very high, it will reduce the amount of sulfur trioxide. Calculate the percentage by mass of a sulfur in sulfur trioxide. So percentage of a sulfur in sulfur dioxide, mass of a sulfur 32, mass of a compound 32 plus 16 times 3, which is 48 plus 32. So total mass of a compound will be 80 multiplied by 100. Because this is 48 and this is 32. So the total sum will be 80. What's the percentage of sulfur in this sulfur trioxide? So it is 40% sulfur is there in this sulfur trioxide. Concentrated sulfuric acid is a dehydrating agent which can chemically remove the water. So this is actually a definition of a dehydrating agent. Dehydrating agents are the one which can chemically remove. If it was a drying agent, it will physically remove the water. Like silica gel, um, uh, copper sulfate, anhydrous copper sulfate. These are drying agents. Sodium sulfate, calcium sulfate as well. These are drying agents which can physically remove the water. But if it chemically remove the water, we call that as a dehydrating agent. So both hydrated copper 2 sulfate and sucrose, the sugar, can completely be dehydrated by concentrated sulfuric acid. Name the solid product produced from each reaction. If we have a hydrated copper sulfate, that's good. It's important that you will not a blue solid. You're not supposed to say the color of that. You have to name a solid product formed in each case. Like if we have copper sulfate, hydrated copper sulfate, anhydrous copper sulfate is the right answer. So what actually happened if you have a hydrated copper sulfate and you remove the water, so it will become anhydrous copper sulfate plus water molecule. So we have to name this product. So here, as you mentioned, that is anhydrous copper 2 sulfate. And what about the glucose? In that case, we have a carbon, a sugar C6, C12H22O11, and as a result, it will produce carbon and water molecule. So this carbon will be the solid which is produced. Yeah, just carbon will be a solid. Water is removed from that. Like if I remove water from that, like if I remove H2O, so what I'm left with? I'm left with C. And same thing, hydrated copper sulfate, if I remove water, I'm left with CuSO4. That's the question. That what solid we are left with. Then propanol, which is an alcohol, it's heated with a concentrated sulfuric acid as a catalyst. An unsaturated hydrocarbon is formed. If it cannot happen for a methane, because how methane will produce water? Methane does not have any oxygen, so it won't produce water. It's a compound which contains carbon, hydrogen, and oxygen. So when we remove the water, it gives carbon. What is meant by the term unsaturated? This is not correct here. Why it is not correct? Because the question is related to the organic compounds, unsaturated hydrocarbon. So unsaturated hydrocarbon means it contains carbon-carbon double bond. So because the question is related to a propanol form an unsaturated hydrocarbon. That is the question. Like propanol form an alkene. So which alkene or propanol will form? Which alkene will be there? So it will form propene or propanene. So state what is meant by the term unsaturated in this one. It means it contains carbon-carbon double bond. Write a chemical equation for this reaction. So propanol means C3H7OH, and we use a concentrated sulfuric acid is a catalyst. So as a result, it will produce C3H6 propene plus H2O. This is called the elimination reaction, in which we get from a chemical compound like one small molecule is being removed. So we call elimination. Name the unsaturated hydrocarbon. So that is propene. Is it clear, this question? So this was topic 6.